Imagine planning a massive university mixer. You have hundreds of students coming from two different groups, the Computer Science Club and the Artificial Intelligence Club. Each club sends you their own guest list in a separate spreadsheet. To get your final headcount, you have to bring those two lists together into one master document. If you just copy the AI list and paste it at the bottom of the computer science list, you run into a problem. Students who belong to both clubs are now on your list twice, meaning you'll accidentally send them two invitations. Managing that overlap manually, checking every name one by one, is slow and makes it easy to miss people. This is where a database system helps. Think of it as a smart filing assistant that can merge these lists for you instantly. To do this, it uses set operations. These are just simple tools that tell the database how you want to combine or compare your collections of information. Before the database can mix your lists together, it needs them to be in the same format so they actually fit. Think of it like stacking two blocks. They need to be the same width. If your first list has 3 columns of info, your second list needs 3 columns too. The information in those columns also has to match. If you stack ID numbers on top of names, the database won't know how to read it. Everything has to line up perfectly, ID with ID and name with name. Once the lists are organized this way, the database can finally look at the data inside and start comparing them for you. Our first tool for this is called Union. This is how you create that clean master guest list. When you tell the database to union the two lists, it stacks them together. But here's the helpful part. The database automatically spots students like John Smith who appear on both club rosters. It drops the extra entries, giving you a final list where every name appears only once. Now, imagine your goal changes. You aren't sending invitations, you're buying meal tickets. If John Smith is in 2 clubs, he gets 2 meals. For this, you use Union All. This command stacks the lists but keeps every single row exactly as it is. John Smith stays on the list twice, ensuring your final count includes every single enrollment. So you use Union when you need a list of unique people, and Union All when you need to count every individual transaction. Sometimes you don't want a combined list at all. Maybe you want to find students who are eligible for a dual major prize. For this, we use Intersect. Instead of merging the lists, this tool looks at both and keeps only the names that appear in both places. It's an instant way to see exactly who the two groups have in common. Finally, imagine you need to find out which students registered for the party but haven't paid their entry fee yet. You use Accept. You take your list of registered students and tell the database to remove anyone who also appears on the paid list. Because the database can compare thousands of rows in a heartbeat, these operations make it easy to isolate specific groups of people without ever having to manually scroll through a spreadsheet. While these tools are great for party planning, they are used every day to manage much larger systems. In a hospital, doctors use these same steps to compare patient lists from different departments, helping them see if a patient is accidentally being prescribed the same medicine by 2 different clinics. Online stores use them to compare what you've bought in the past with what's currently in their warehouse, figuring out exactly which new products to show you. Whether it's Union to merge, Intersect to find common ground, or Accept to find what's missing, these 4 tools handle the heavy lifting of sorting through data. Learning these set operations is a major step toward mastering how databases work, turning a messy pile of information into an organized, useful resource.